This unit is about collecting data. So in a lot of ways, honestly, guys, this is probably what I should teach first. All right. Because, right, this class, the very first thing that we did, if you think about it, was we did data analysis, right? We said, hey, let's imagine that we had a set of numbers, like let's try and see patterns in this data and whatever. Well, really what came before having that list of data was collecting that data. And that's going to be what we're talking about in this unit today, is how do we collect data in meaningful ways, and what are some bad things that can happen when we're collecting data, and how do we avoid those things, different ways to take samples. All right. In a lot of ways, logically, this goes first. I don't like I used to actually teach it first, but I don't like teaching this unit first because it's very dry and it's just not a good way to get the year off on like a good foot. It's a lot of vocab and stuff. I don't get super hyped to teach it, but it's not because it's not important. It is super important. I just like to do stuff with numbers, and this has no numbers in it really. All right, so we'll go through some of this vocab today. Some of the things you'll be familiar with, some of the stuff we will have kind of talked about in previous units. All right, so we need to be familiar with 5 different ways that we collect data. We talked about simulations in the last unit, or actually in unit 10. All right, this is more used for probability-based applications when a problem is very complicated and it's very hard to solve empirically, so we just use a simulation to kind of represent the problem, and then we can estimate the probability of something using that simulation. All right, so we're not going to get into simulation very much in here. We're going to talk about these two, observational studies and experiments, next class. All right, these two are similar. All right, there's a very subtle difference between the two, and we'll talk about those next class. All right, we just need to know the difference between a census and a sample. All right, you guys are familiar with the census. All right, in statistics, a census is anything where you collect data from your entire population of interest. So you collect data from your entire population. All right, so if Hood was studying Madison students, if he were to go to each student and say, hey, how much time are you spending per week on homework or something, and he asked that to everyone, that would be considered a census. So anytime you're collecting data from everything, that's a census. All right, now a census is ideal because you have all of the information. You can generate parameters from that. So when I say parameters, you could calculate the true average amount of time spent doing homework. That would be mu in that case. You could calculate what percent of people do X, Y, or Z. That would be P. All right, a lot of times though, we can't do this for practical reasons, right? It either costs too much money or takes too much time or is just difficult. In fact, the US government does the census every 10 years, is that right? All right, yeah, so they do it every 10 years. I'm sure that they would like the data more often than that. It's just hard to get data from everything, all right? It takes a long time just to collect it and then compile it and to go back and ask people again. So a lot of times when we can't do this, what we'll do instead is we'll just get a subset and take a sample from some small group. So this is collect data from a subset of your population. I'd like to ask everybody, it's just not happening. So I'll take a sample, sometimes called a sample survey, and we'll just get some of our individuals. And we're going to talk today in a little bit about different ways to take a sample. I actually should move this to another page. I'll talk about this right now. When we start getting into talking about what can go wrong with a sample or a survey, we're going to be mostly looking at these elements. So I don't know if I told you guys this. My undergraduate degree is in quantitative psychology. So like I did the stat that goes into psych experiments. And so I took a lot of classes on this type of thing, how to give a good survey. Like if I want to, in fact, why I went into that is because I was super interested in like how do you quantify like intangible things. Like I was really interested in like how do you measure like how smart somebody is, or actually I was super interested in like the NFL draft and like how do you quantify how good someone is at football and like things like that. Like how do you measure and quantify these things that are kind of abstract? And I learned that like it's just like kind of people make it up. All right, which was kind of disappointing, but it is what it is. All right, well, one of the things that we talk about whenever we design a survey or whether we're creating something to measure intelligence or measure athleticism, one of the things or two of the things that we're going to be interested in that instrument that we're using to get these measurements is this thing valid and is it reliable? Does it have validity and does it have reliability? All right, validity you can kind of think of as accuracy. Does this thing truly measure what you're intending to measure? All right, so if I'm trying to measure something abstract like intelligence, this is something that's very hard to touch on. In fact, like, what does that even mean? All right, well, if I designed, okay, my experiment, how I'm gonna measure intelligence is I'm gonna have you recite the ABCs frontwards and backwards as fast as you can, and I'm gonna time you. And if you can do it fast, then you're smart, and if you do it slow, then not smart. All right, I think that that's probably kind of like a nonsensical approach to trying to measure somebody's intelligence. You would say that approach lacks validity. That's not really measuring what I'm intending to measure. Does that make sense? All right, so if you see a question and they're asking about, hey, can you comment on the validity of this study? What you want to talk about is this study really measuring what they're trying to measure? All right, that's what we're talking about. All right, that's different from reliability. Reliability has to do with consistency. All right, so does or would this instrument provide repeatable results if I gave it multiple times? Here's something that's super reliable, a scale. All right, I'm trying to measure my weight. All right, if I step on a scale and then I get off and then I step on the scale again, that scale better tell me the same thing when I stepped on it the first time as when I stepped on it the second time. It's providing reliable measurements. All right, when we're talking about some of these more abstract things like the SATs is an attempt to measure your your aptitude, your academic aptitude. Whether you believe it or not, the SATs has been shown to have fairly good reliability between forms. So if you were to take an SAT 1 week and then take another form of the SAT the next week, you may not have identical scores, but you're going to have fairly similar scores because those tests have been shown to be fairly reliable. Now, if you take it like 1 month and then you take it 6 months later, all right, maybe you've done some tutoring, maybe you've learned some new strategies about how to do the test better, all right? In that case, you've actually gotten better at taking the test, which is a different thing. But in general, that test tends to be fairly reliable, and we want to give something that is going to consistently measure whatever it is that we're intending to measure. All right, so if you see a question that's talking about the reliability of a study or an experiment, what you want to talk about is, hey, if they were to do this again, should I expect similar results, and why not? All right, that would be what you want to talk about. Questions on these two elements. All right, really these two types of things should belong later when we talk about other things that can go wrong with sampling and with studies, but we might as well talk about them now. Questions on either of those two? Okay, then let's get into different ways to conduct a random sample. So we've had a lot of problems this year where they've said, hey, we went out and we took a sample of things. All right, and so far this year we've kind of just glazed over it and we were just like, hey, we want it to be random and that's all you guys cared about. All right, there's actually different ways that we can take a random sample, and some of them have additional benefits depending on what our goal is. All right, so the first type of sample is called a simple random sample. You might see the term SRS places. All right, that just stands for simple random sample. A random sample means that I'm going to give you the poor man's definition first because it's easier to understand, that every individual has an equal chance of being selected. I almost spelled selected wrong. Really, the definition is that every group of size n has an equal chance of being selected, which is actually a different thing. And most of the time, when one of these is true, the other will be true, but there are cases where we could make one true and not the other. All right, so what these pictures are, and I've got some pictures on the following pages, is just a way for me to kind of demonstrate the differences between these sampling techniques. I got this from a book, Statistics for Dummies. Is that bad that your math teacher has a Stat for Dummies book? Anyway, I liked the example that they used. So the example that they have here is that they were like, hey, imagine a lady just got her hair cut. She just got a fresh new cut, and she wanted to know what the public's opinion was on her haircut. So she wanted to survey people, mall goers, and ask them, hey, what do you think about my new haircut? Because that's a normal thing that people do, is ask strangers about haircuts. So this first one, all right, all these X's denote people that are in the mall. This first one just denotes her taking a random sample. All right, so I'm not exactly sure how she did this selection. We're going to talk about how you could actually select people at random. All right, it'll usually involve giving each person a number and then drawing that number from a hat. That's how I'm going to have you guys do it. All right, there's different ways to do random things, but this first one, fairly random. We've got a bunch of people in the mall, and then we picked, it looks like 6 people, and those are the 6 people that we sampled. All right, so that would be a simple random sample. All right, now a simple random sample is, I'm just gonna say, we'll put this up here, or right here. A simple random sample is mathematically we're gonna put best. All right, a lot of proofs of the processes that we use need our sample to be a random sample, or assuming that it's a random sample. So from a math standpoint, it's best, but in actuality, it has some flaws that we might not like. All right, we're going to talk about that in a second. All right, so mathematically, it's the best, but here's a flaw with it. All right, and this is true in a lot of different applications. Let's imagine that this woman's got her hair cut. She's worried that people might have differing opinions on it. All right, she's worried that men and women might feel differently about her haircut. All right, that, I don't know, she's got some controversial cut, and she thinks that one of those two groups is going to feel different from the other. All right. If she were to do a simple random sample, all right, she opens herself up to, just by bad luck, getting too many of one type versus the other. So it's possible that she could just end up with bad luck and get 6 guys in her survey, or get 6 women in her survey. That's possible. And if that were to happen, she would be overrepresenting one opinion versus the other. This is something that if you're doing political surveys that you have to worry about. When you do a simple random sample, it's possible that you overrepresent one political party versus the other, and that's going to influence your results. All right, so how can you avoid that type of thing? All right, well, one of the things that you can do is you can conduct what's called a stratified sample. All right, a stratified sample is where you break your population into groups and take a random sample from each group. All right, so here she broke them all up into men and women, and she took a random sample of men, and she took a random sample of women, and that guaranteed that she got individuals of a good blend that she wanted. All right, if you were doing this politically, you could just make sure, okay, I want to get Democrats, Republicans, independents. All right, and you could choose how do you break that down if you wanted to have certain, I don't actually know what the political breakdown is. If you wanted to have more of one group versus the other, maybe you have less independents and more of the other two parties, I'm not really sure. All right, what you want to do whenever you're stratifying, you want to make sure that your strata, that's what these groups are, should be impacting your results. So you don't want to stratify by something that doesn't matter. All right, so like, I don't know, if she was asking people about her haircut, she wouldn't want to be like, oh, I got to make sure I get some tall people and some short people. All right, there's no reason to think that tall people and short people are going to have a different opinion on her haircut, so you wouldn't need to stratify by that. All right, you should only stratify by things that you think are going to impact your results. All right, stratifying we do to achieve a particular goal or to achieve a particular blend in our final sample or final result. All right, we do this next sampling method for a different reason. Cluster sampling we do to make taking the sample easier. We do this for logistical reasons, to make it more practical, to make it more realistic. All right, so a cluster sample, let's imagine that now the lady, she's not super mobile. All right, she's older, and she's got one of those walkers with the tennis balls on the bottom. All right, so she's just shuffling around the mall and doing this. This is just because I got to go back and forth and all over the mall to get this sample, and that just does not sound good to her. All right, so what she might do, and what a cluster sample does, is you break your population into naturally occurring groups. Usually it's by location. That's usually why you would do this. You randomly select a couple locations or a couple clusters, and you survey all of the individuals in those clusters. All right, so again, you're going to break your population into groups. And this now is usually by location. This is the most common method of stratifying, although not the only way. You randomly select, I don't know, several clusters. And sample everyone or everything in those groups. In those groups. So at the mall, your mall is already naturally broken up into stores. You've got stores in the mall. So what she thought to do is she would randomly number the stores, randomly pick a couple of stores, and then survey all of the individuals in those selected stores. So that way she only has to go to 3 spots and she doesn't have to walk all over the mall to do this. All right, it just makes taking the sample easier. All right, it's not great from a math standpoint. It's not great at achieving specific blends like stratified, but sometimes you do things for different reasons. And if taking the sample is hard, then you might do this for that reason. All right, similar to cluster sampling, another thing that you can do in very specific applications to, again, makes taking your sample easier is you can take what's called a systematic sample, where you sample every nth individual. All right, so you'll pick some point, and again, you can only do this in certain applications and scenarios. So at this mall, if you imagine that the mall only has one entrance, everybody would have to go in through that entrance. And so she's like, oh, well, since everybody's got to come in this entrance, I can just survey every third person as they go by. And that's going to be just as good as maybe taking a cluster sample, maybe even arguably better. And I have to do even less walking. All right, again, you can't do this in every application. All right, but it works in certain types of things. You might do this at a stadium before a sporting event. You might do this if you're in quality control at like a factory or you're producing something and you're looking at every 100th item that comes off the line. All right, there are applications where this type of sampling works fine. All right, the last one is bad. All right, convenience sample is you take whatever is easiest. This is not random. And this is bad. Take whatever's easiest. That's what it says. So maybe rather than go to the mall, she's like, I'll just ask my friends what they think of my haircut. Honestly, that might be the only thing that matters, because who cares what strangers in the mall think? But whenever you take what's easiest, you're often going to have inherent what's called bias, and we're going to talk about what bias means in a statistics class another day. But usually what that's going to mean is that all of your individuals that you're surveying are going to be similar in some sort of important way, and that's going to push your results in a particular direction. So like, let's say I was trying to survey Madison students about some topic, and I was just like, I'll just ask my kids, all right? While that would be super easy for me, the problem is if I just ask you guys, everybody in here, or I think in this room, but in most of my classes tend to be upperclassmen, so all tend to be 11th or 12th graders. Occasionally I'll have the 10th grader, but mostly it's 11th and 12th graders. So I'm overrepresenting that group, and I'm underrepresenting underclassmen, 9th and 10th graders. In this class, I'm taking only AP students, and I'm underrepresenting people that don't take an AP math class. All right, so there's all of these types of things that are going to happen when you take a convenient sample that's going to influence your results and potentially result in you getting a bad sample. All right, I want to just go over one more thing. The two types of samples that kids mess up are stratified and cluster. All right, they're very similar in that they involve breaking your population up into groups, and so I find that if kids mess up in this unit, it's confusing those two things. All right, I don't know if this is helpful, but Mr. Burkle teaches this, and I don't hate it. All right, a stratified sample, you break your population up into like groups, and you take a little bit from each of your groups. Mr. Burkle calls this sum from all. You're taking some of your individuals from all of your groups. I actually don't know if he made this up or if he read this somewhere, but I'm going to give him credit. All right, he calls this sum from all because you're getting some individuals from all of your groups. The benefit of this is that it gives you a good blend, so it's going to represent all of those groups. All right, a cluster sample, again, you're breaking your population into groups, but now I'm randomly picking a group or two, or however many, and then I'm surveying all of the individuals in those selected groups. This is all from some. You're getting all the individuals from just some of the groups. This is better because I have to go to less places. And again, you do these for different reasons. Do we have questions about either of those two sampling methods? All right, we're going to go over one last thing, and then we're going to call it a day. All right, if we skip ahead to here. All right, I want to just talk about, and I don't actually know if you still need to be able to do this. All right, but you are going to need to be able to describe how to take a random sample. All right, so I want to, talk to you guys about how I want you to describe it, because that is something that they might ask you. All right, one of the more common things that they'll ask about on a free response section, all right, is they'll say, hey, I've got a group of students here, and I want to randomly select 3 individuals to be in some group. Describe how you would conduct a simple random sample in this case. All right. There's a lot of ways that kids will do this that unfortunately are not descriptive enough. All right, so a lot of kids will do like stuff with random number generators on your calculator. Have you guys ever used a random number generator on your calculator before? All right, don't worry about it. I don't want you to use it. All right, but they'll do these things with random number generators, and it's fine. Those aren't wrong, but you have to be really super descriptive in how you do it. And there's a lot of minutia and details that kids often leave out that will cause them to get partial credit. If you guys are ever asked to describe how you're going to do a random sample, this is what I want you to do. All right, whatever your group is, if it's people, all right, say you'll write down all of their names. Or if it's something that's more abstract, like let's say I'm randomly selecting some plants. Give each plant a number, all right? So you're identifying each of your individuals. You put those names or you put those numbers on individual sheets of paper. You put the paper in a hat, and then you draw out of the hat. That's what I want you to do, and I want you to describe it like I just described it right now, all right? It may seem like childish, but that is the most foolproof way to take a random sample of things where it's really hard to mess up the description, all right? A lot of other ways to do it is easy to mess up. It doesn't matter if it's a really big number, like let's say I was randomly selecting people from the state of Rhode Island. I don't care. You write down every Rhode Island person's name on pieces of paper. You put those paper in a big hat. Put it in a big old hat, and then you draw it out of the big hat. All right, that's what I want you to do. I had a kid one year that whenever he would do these problems, he would just make it he would describe in detail what type of hat it was. So it'd be like a green cowboy hat with feathers and sequins on the front. Like he would describe the hat. It was a good bit. All right, I don't need you to do all that. But at any rate, that's what I want you to do if they ask you to do it. I don't know that they're gonna, that this is still something that's on the AP exam, but I'm gonna show you guys once just in case how to use a random number table to do a random selection. So I think I showed you guys how to use a random number table to do a simulation with the frogs. You remember that? All right. So with the frog jumping left and right. All right. I don't know that this is still on the exam, but on the off chance that it is, if they wanted you to use this random number table to select 3 people from this group, all right, what I need to do is, since these are numbers and these are names, I need to turn these names into numbers. So what I'm going to do is I'm going to give each person a numeric code. All right, I've got, I think it's 20 people in this list. All right, so I'm going to number them 1 to 20. But since 20 is a 2-digit number, my biggest number is a 2-digit number, all of my numbers need to be 2-digit numbers. So instead of going 1 to 20, I'm going to go 01 to 20. And it doesn't matter if you number them down this way or number them across. I'm going to number them down this way. But it doesn't matter how you number them, other than they all need to have a 2-digit code. Aiden, here you go. All right, give everybody a 2-digit code. All right, since everybody is a 2-digit number, if I want to use this random number table to make selections, I'm going to look at the first 2 digits and I'm going to say, is that a person in my list? It is not. All right, so I'm going to cross off those 2 numbers. I'm going to go to the next 2 numbers. All right, do not use the 2 over again. You want each selection to be independent of the previous one. And if this first number had a 2 in it, you don't want to reuse that 2, all right, because that would make it influence your next selection. All right, so then I'm going to go, okay, 63. That's not on my list either. Then we would go to the next 2 digits, and I know that there's a space, but that's okay. We're going to use that number right there, 7. 7 is a number that's on my list. 7 is Nick. All right, and then I'm going to go to the next one. 82, no. 40, no. Okay, 19. 19 is Steve. All right, 26, 79, 54, 57, 79, 44, 57, 87, 35. Kind of tedious. Again, I think this is why they kind of took this off the exam, or it's not frequently featured on here. All right, so here we got 19. All right, now that's somebody on my list. All right, but 19 I already sampled. All right, so obviously that person can't be in my sample again. I'm already using them. So I would skip this number just like I skipped the other ones. This is actually why I don't want you using things like a random number generator when you describe your method, because you have to describe repetition rules and you have to describe in detail the numbering system and all this type of stuff. So that's why I want you to use the hat method. All right, skip this, 65, 00, not on the list. 04 is, and 04 is Garvey. And that would be my sample. I don't think that you're going to be asked to do this. It's been a while since they've asked a kid to use the random number table to do a sample. It's much more often where they'll say, hey, we've got this list of kids, describe how you would take the sample. And that's where I want you to describe doing that with the hat. Put all their names on pieces of paper, draw 3 names. That would be your sample. Done. Questions on any of that? Okay, we're going to stop there. Next class, we're going to talk about different types of bias, and we're going to get into designing experiments and different things that can be found in experiments. And then that is it.